In the previous video, we talked about the concepts of deductive validity and deductive invalidity. This video is about some other logical concepts. Recall, to say an argument is deductively valid means that it's impossible for the premises to be true and the conclusion false. To say that an argument is invalid means that it's not valid. Or to spell it out, to say that an argument is invalid means that it is possible for the premises to be true and the conclusion false. If you have more questions about validity or invalidity, you can go back and watch the previous video, you can look in chapter 1 of the textbook, or you can attend one of the study sessions. The rest of this video will be about some other concepts. For our purposes, a sentence is something with a truth value. It's either true or it's false. Notice that this already leaves out a lot of the English language. That is, in English there are interrogative sentences like, "What are you doing?" with a question mark at the end. But remember that our interest is in arguments. The question, "What are you doing?" doesn't give you a reason to conclude anything. Of course, the sentence, "Someone just asked you what you were doing," might give you a reason to conclude something. You might conclude that they want to know what you're doing, for example. We're also going to assume that the only possible truth values are true or false. Now, as a philosophical matter, you might think that there are some sentences which have intermediate truth values, which are a little bit true or somewhere between true or false. And that's fine, but we're going to set that concern aside for this course. And the logical systems we're developing later can be added to, can be supplemented. That is, logical systems with 3 or 4 truth values often build on the kinds of systems we're developing in this course. So it's really a kind of technical simplifying assumption we'll make. All right, with that conception of a sentence in place, consider this sentence. All monkeys are monkeys. Is it true or is it false? Well, of course it's true. It just has to be true. If you're using the word monkey, the same sense in both places, then all monkeys simply must be monkeys, right? If they're monkeys, they gotta be monkeys. So we have a word for a sentence like this. To say that a sentence is a tautology means that it must be true, just as a matter of logic. So the sentence, "all monkeys are monkeys," is a tautology. Now consider this sentence. Everything comes to an end. Is it a tautology? You might want to pause and think about this. Well, no, it's not. But why? Maybe it actually is true. Maybe it's true not only that everything comes to an end, but that everything has to come to an end because of the laws of physics, because the way the universe is put together. But maybe not. Maybe there are some things that never end. Maybe God, numbers, or time itself. Those are all the issues for a different course. What matters is that even if this sentence is true, it's not true just as a matter of logic. We'd have to figure out that it was true. All right. So consider this sentence. Some monkeys are not monkeys. This seems like the opposite of a tautology. And it has to be false. It has to be false just as a matter of logic. We'll call sentences like this a contradiction. To say that a sentence is a contradiction means that it must be false, just as a matter of logic. Now consider this sentence. Some monkeys like bananas. Is it a tautology or a contradiction? Think about it. I think it's true, actually, but I'm not sure. Remember, though, that whether it's actually true or false isn't the issue. Maybe it is true, maybe it isn't. It depends on what monkeys are like. So it's neither a tautology nor a contradiction. And we'll call a sentence like this contingent. To say that a sentence is contingent means it is neither a tautology nor a contradiction. To summarize, a tautology must be true, just as a matter of logic. A contradiction must be false, just as a matter of logic. A contingent sentence might be true or false, depending on what the world is like. All right. Consider these two sentences. Romeo loves Juliet. Juliet is loved by Romeo. Now the first one is contingent. Maybe Romeo loves Juliet, maybe he doesn't. Second one is also contingent. Maybe Juliet is loved by Romeo, maybe she isn't. Still, logic allows us to say something about these sentences. And it can't be that one of the sentences is true because we don't know. It's logically contingent. It can't be that it's false. But if one is true, the other must be too. And if one is false, then the other must be also false. That is, they have to have the same truth value. That is, they're logically equivalent. They've got to have the same truth value. To say that two sentences are logically equivalent means that they must have the same truth value just as a matter of logic. Okay, now consider these sentences. Every aardvark is ill-mannered. Chester is not ill-mannered. Chester is an aardvark. So the first sentence is contingent. Maybe every aardvark is ill-mannered, maybe not. Chester's not ill-mannered? We don't even know who Chester is, but it's logically contingent. Maybe he is, maybe he isn't. Now, Chester is an aardvark. Well, again, it's contingent. So, can we say anything about these sentences as a matter of logic? You might be tempted to ask whether it's valid or invalid. But remember, validity or invalidity is a feature of arguments. There's no therefore here. None of the sentences is offered as a conclusion. And since it's not an argument, we can't even ask if it's valid or invalid. The question just doesn't arise. Still, these sentences together have a logical feature. Can you see what it is? Maybe you want to pause the video and think about it for a minute. So, these sentences can't all be true. At least one of them has to be false. Now, logic can't tell us which of these sentences is false, but they just don't all fit together. If every aardvark were ill-mannered, and Chester were an aardvark, then he'd have to be ill-mannered, so that second sentence would be false. If Chester was not ill-mannered and was an aardvark, then it would be false that every aardvark is ill-mannered. And finally, if every aardvark really is ill-mannered and Chester really isn't ill-mannered, then Chester can't be an aardvark. So we'll say that these sentences are inconsistent. They can't all be true together. That's just a matter of logic. But logic can't say which sentence on this list is false. Maybe they're all false. Maybe two of them are false. Maybe just one of them. All we can say as a matter of logic is that they can't all be true. So to say that a set of sentences is consistent means that it's logically possible for them to all be true together. To say that a set of sentences is inconsistent is to say that it's not consistent. That is, it's logically impossible for them to all be true together. We've gotten a bunch of logical concepts now. These are also discussed in Chapter 1 of the textbook, For All X. You can rewatch the videos. I know it's gone by quickly. You can also take a look at the textbook and read what I say there. So, one thing to note about them is that they all apply to different kinds of things. An argument is valid or invalid. A single sentence will be a tautology, a contradiction, or a contingent sentence. Two sentences will either be equivalent or inequivalent. And a set of sentences, or list of sentences, will be consistent or inconsistent. Now this is an important point because, as we saw earlier, you can only ask if something's valid if it's an argument. Similarly, you can only ask if something's a tautology if it's a sentence. You can only ask if two things are equivalent if there are two things. You can't ask of one sentence whether it's equivalent. It doesn't even make sense. So when you're thinking about the concepts, when you're learning these logical concepts, keep in mind the kinds of things they apply to. Now, a final point. Applied to the right kinds of things, these are all features of ordinary English. This is important because soon we'll start constructing formal languages and translating from English into those formal languages. We want the logical properties that the formal languages have to reflect the properties from English. When we construct sentential logic, we want the arguments that are valid in SL to be translations of ones that are valid in English. We don't want it just to be some strange mathematical thing that we made up.